finally all my bits have arrived. I've got to mount it all together now. Obviously I just wanted the same setup with more height so I can do variations on different velocities. But you can only, these come like from CNC, you know, for the linear bearings, you know, that kind of thing, CNC machining, so they don't come threaded. So I've had to buy a heavy base, which did come threaded, but obviously I can't get that threaded. But they do sell these little mounts that the rod goes into, and then there's like little grub screws on the sides that lock it off. So I bought one. Obviously I've drilled that so that fits and I can bolt on. But because it locks either back to front or side to side, it wobbles because obviously it's quite long and hefty. I think it's about 1.2 meters. So I bought another one so I can mount one on the bottom in one orientation and then one on the top in the other orientation, so I can lock it off from side to side and back to front. So I can also set square it so it's perfectly perpendicular to the base. And then I've got a platform washer, which I've just realised it's square because I was using a round one and that's on the piss, but yeah, there we go. It's all drilled by hand. That was a bitch. Ooh. So yeah, basically that'll be on the one on the bottom, one on the top. The rod will pass through, lock off at the bottom, lock off at the top, and then that plate will go on top. So we'll get it all bolted together. All bolted together now. The plate's on the piss, as I said, but it doesn't matter. Heavy base it is. I've replaced those little grub screws with longer Allen key bolts because the Allen key for the grub screw is so thin and so tiny, it was just a pain in the arse. So yeah, all bolted together now. It's got rubber feet on, so it grips exceptionally well, even without being taped down. So there it is. So the rod passes through, bolts top and bottom, and there we go. It's the early hours of the morning, and I thought I'd have a go at this, so I started getting all my bits out. Not in public, obviously. But yeah, got all the bits here. I got them all unpacked and bolted together. So I've got this new base, the rod, I've got to bolt them together. That's my tripod. I've got my essential water because I'm full of cold at the moment, so I need plenty of fluids. All bolted together now, top and bottom. The rod, I think, measures about 1.2 meters, but obviously with having to go through the base, that takes a bit of length off, and then obviously there'll be the spring, so that'll take a bit of length off. So I don't know what I'll be left with in regards to heights. I'll have to work that out when I get to it. But you know, certainly gives me a bit more height. So this is just to show now that I've eliminated the wobble, which was a bit of a pain previously. So as you tilt it now, it's fully connected to the base. You know, there's no flex, there's no wobble. Because like I say, just with the one fitting, it was wobbling. Right, a few more bits needed because I've got to measure the weight, dead weight compression on the spring. So I need my other bits also. So we'll get on to that. The other lab stand here, so I can suspend the other rod and get the calipers in and measure. All the fittings are there now. I've got the rods, the calipers, the grips and everything, so I'll attach it all. Rod suspended now with the one mass on the spring, so I can measure any dead weight compression on the spring. Spring uncompressed measures in at 103.3 millimeters. So with the one mass on, this is tricky to do with one hand and holding the camera. So
That's the gap there. And we've got 103.3, so there's no weight compression for the one mass. So we now have a probe that is 25 times the mass. So just measuring from that bottom washer to the bottom of the mass again, fiddly with one hand. So again, there's the gap, and we're going to have some compression here. We've got 98.6. So mass is here. We've got a one mass at 26 grams. Now shiny new one. I'll weigh that again, and that's 26. So 25 times 26 grams would be 650 grams. And we've got 649, so just a gram off. Yeah, 649. Tea break. A lot of bloody work this. Let's get on with it then. Tape down, ruler in place. The ruler's in line with the spring now, so it's in the same position. I've had to move it out a bit because the 25 mass is chunky, and obviously it will hit, so slightly different setup. So here I've just made a crude 4cm spacer. So tape measure on here, just showing that it is 4cm. Like I say, quite crude but effective. So just showing the spacer in now, 4cm. Stop set, I'm holding it up against the stop. This will be the 25 mass 1 velocity. Just showing the distance for the one mass, so the one mass is on top of the spring, and then I'm just measuring to the bottom of the stop, so obviously when the mass is pulled up it'll be the same measurement, so that'll be a metre or thereabouts. Just showing the whole setup now, so everything taped down, lights taped down, phone fixed in position, tripod taped down, obviously the setup taped down, so it's all taken from the same perspective.
So the 25 mass is just 2 linear bearings, 2 probes taped together, and then I've added lead weights from the centre out, so it's weighted from its centre of mass. So basically the idea behind this one is we're just dropping a 25 mass from one height, which will give us 1 velocity, which will give us a momentum of 25, and a 1 mass from 25 times the height, but we'll be going 5 velocity. So we've got 1 mass, 1 times 5 equals 5. So in this instance, we've got 5 times the momentum in this probe. But in terms of energy, obviously half the mass, so 25, half is 12.5, velocity would be 1 squared, so that gives us 12.5. Half the mass of the one mass, velocity would be 5 squared, 25. 0.5 times 25 equals 12.5. So in terms of energy, when dropped, these should be pretty equal. It's basically the same as the previous one, where I dropped a 1 mass from 4 heights and a 4 mass from 1 height. It's just, you know, changing the mass ratios and the distances, but it's the same principle. It's the same rule of thumb. We should see very similar compressions or work done on the spring, minus the dead weight. I will upload the footage separately because I've got a Bluetooth it all over, carry it all, take off the dead weight measurements and so on, and it's in a different aspect ratio. So I'll review that later and hopefully get it uploaded pretty quick. And thanks for watching, everyone.